Next thing we're going to look at in today's lesson is ladders. And I think we're going to be able to go a little bit faster because you've done some of these for homework. If you have done them for homework and found them tricky, this will reinforce the ideas because it's slightly easier, and these are a really common kind of question that comes up. We're still going to be doing the same 3 things that we did before: resolve, resolve, take moments. Usually with the ladder, we will be taking moments from the bottom of the ladder. That's usually where we take them from, bless you. So here we've got a ladder AB of mass M and length 3A, has one end A resting on rough horizontal ground, but the other end B is on a smooth vertical wall. We have a load of mass 2M, so I'm going to add in that this is 2mg over here, is fixed on the ladder at the point C, where AC is equal to A. The ladder is modelled as a uniform rod in a vertical plane, perpendicular to the wall, and the load is modelled as a particle. The ladder rests in limiting equilibrium, which it has to be, really, to do any of this stuff with mu, at an angle of 60 degrees with the ground. We're going to find the coefficient of friction, and then we're going to talk about some of the assumptions that we've used here, okay? So, just what this looks like, it's literally like a ladder resting against a wall, like this ruler that I've got here, resting against it. What else did I want to mention? When it says it's in a vertical plane, perpendicular to the wall, it's just saying it looks like the way that I've got my ruler rested like this, rather than at a wonky angle like that, where it's all going at funny angles. So you don't need to worry about what that sentence says. It just means it's going exactly like it looks like in the diagram. So what other forces do you think are acting on this ladder? Yeah, Sufyan. Good. The resultant force from the ground, which I'm going to give the letter R, and the resultant force from the wall. I can't remember what letter I used with the other group. I think I might have used the letter N here. Obviously, we don't write newtons on our diagrams, so we can use the letter N if we want to. And then, what other forces? There's still some more to go. Yeah, Mizakir? Yeah, friction. Which direction is the friction going to go? To the right, because we think it's going to be slipping, so there's going to be friction here. Is there going to be any friction here? If there was friction here, which direction do you think it would be going? It would be moving down, so the friction would be going up. And you will do a question after we've done this example where there's friction, 2 frictions, friction on the wall, friction on the floor. There's still some more forces that we're missing.
The weight.
The weight. And the weight acts directly in the middle, and we know that the weight is mg. Now, thinking about these distances, if this is A, what is this distance between here and here?
2.
Yeah, it's half A, because the whole thing is 3. So now this is no longer 2A here. This is 3 over 2A. So we've now got it as A, a half A, and then 3 over 2A. The whole thing that was on the diagram previously that said 2A was from here to here. So I'm going to do the 3 things that I've usually done. Some of these are going to be really, really easy. The easiest one, what looks like the easiest one to do? Moments is the hardest one. Good, N equals friction. So first of all, I'm going to resolve left and right. I'm going to get myself some free marks. Let's imagine this is the last question in your last exam and you're panicking. Well, you might as well get a free mark, and the free mark is N equals mu R. Maybe you're running out of time. You might as well get that mark. Why not? There's another easy mark that you guys can get here as well. Good. R, looking up and down, upward force equals the downwards forces. R equals 2mg plus mg, so R is equal to 3mg. Now here comes the tricky part. We're going to try and take moments about A. So here is the bit I'm trying to take moments about. And remember, I've said it's the perpendicular distance from the line of action of the force. What I usually recommend doing is looking at your force and just saying, I'm going to make the line a bit longer. So here's my 2mg force that I've got here, and I'm making it longer. So the distance I'm looking for is this horizontal distance from here. So I'm going to just draw, for this first bit, I'm going to just draw that triangle out. So I've got a triangle that looks like that, with a 60 degrees at the bottom. How long is the hypotenuse of the triangle? A, good. Now this bit down here is not 2mg, that's the size of the force. But the thing I want, do I want this, the bottom or the opposite? The opposite or the adjacent? I want the adjacent. So for this first bit, I know that the distance I'm looking for is A cos 60, and the force is 2mg. So I have 2mg multiplied by A cos 60. That is for this first force that I've got here that I've done in blue. My next one is the line of action of the mg force, which is this distance running along the bottom here, right? The triangle is going to look basically the same, so you may not even need a triangle. I've got 60, but the hypotenuse is 3 over 2a, and again I'm looking for the distance along the bottom. Why is the hypotenuse 3 over 2a?
It's right in the middle.
Why is it right in the middle?
It's uniform.
It's a uniform rod. So now I can say what my next bit is. My next bit is my mg, that's my force, and my perpendicular distance is 3 over 2a cos 60. And this is all equal to, hang on a sec, which is the force that's going to be going in the other direction, which is the opposing force? The n, yeah. Now for this n, I'm going to do my triangle in another colour. Let's get a darker green than that one. I'm going to draw the line of action of the force like this, because remember we're looking for the shortest distance from the point to the line of action of the force. So I'm actually looking for this distance that I've got over here. So I'm going to draw that triangle. I'm looking for that big distance, the angle at the top. Do I know what this angle at the top is? Why? Alternate angles, Z angles, but we're going to say alternate because we're grown-ups. And what's the hypotenuse? 3a, okay, good, 3a. Now I can say that that is all equal to, let's hope I don't run out of space, n multiplied by 3a opposite, so it's going to be 3a sine 60. 3a sine 60. Okay, let me just erase these lines because they're getting in my way, I don't like it. 3a sine 60. Now I know that n is equal to mu r, and I know that r is equal to 3mg. But there's some tidying up that I can do with this equation first of all. Any tidying techniques you can see I can do? Cancel out the a's, so I'm going to cancel out this. Let's do it in a different colour. I'm going to cancel out the a here, and the a here. Can I cancel any m's or g's?
MG.
No, there's no mg here yet, but there might be in a second. Now, I'm going to do something that you're going to say, huh, why are you doing this? I'm going to leave the cos 60 and the sine 60 for a minute, because with these ladder questions, there is a technique that when I do the second example, you'll say, oh, that's actually really quick. That's actually really neat. And I'm just going to leave it there for a second, and I'll show you why, and it will work out for the next example. So I'm just going to now rewrite this line. I've got 2mg cos 60 plus 3 over 2 mg cos 60 equals 3 sine 60 multiplied by n, and n is mu r, okay? Now, n is mu r, but r is 3mg, okay? So instead of writing mu r, I could write mu multiplied by 3mg. Now I can go through and I can get rid of the mg, and the mg. You're still going to be thinking, why is he not writing this out? So I've got 2 cos 60 and 3 over 2 cos 60, which is how many cos 60s? 2 plus 3 over 2? Yeah, 7 over 2. So we have 7 over 2 cos 60 equals 9 sine 60 multiplied by mu. Now, obviously, I could have put all of that stuff in my calculator way, way quicker. However, there's a technique that is going to be useful for you, which gets rid of a cos and a sine and combines it into a tan. Now, the reason this is useful is because in this question, I told you the angle was 60, but in some questions, they might tell you that tan alpha is, I don't know, 3 over 7. And this, if you can combine a cos and a sine into a tan, you can then just use the information the question gives you rather than having to have any ugly surds and stuff in there, okay? So although you don't need to do it now, I'm going to show it to you now so that in a question in a second where we have something that was like this, it will work out even better. So I'm just going to divide everything by cos 60. Like I've just said, you could just put this in your calculator. You could do 7 over 2 cos 60 divided by 960. But I'm just going to show you this technique because it will help us in all ladder questions, well, 9 out of 10 ladder questions. So if I divide by cos 60, I get 7 over 2 equals 9 tan 60 times mu. So mu is equal to 7 over 2 divided by 9 tan 60, which is, you got it, Hamza? No?
No,
I thought you were ahead of me.
no, I'm a bit confused.
So you get 7 root 3 over 54. That's if we wanted an exact value, or 0.22 to 2 significant figures. Now, at this stage here, I was doing all this mad stuff going from sine and cos into tan. You could, just from this line that you've got here, you could just solve the equation and find out what mu is. But you just need to trust me, because there's this technique that will save you some time in the future, and it will save you feeling like bogged down by loads of horrible algebra and stuff like that. Not algebra, but surds and things, okay? That's part A of the question. And then part B would just be a 1 mark. State how you've used it, the assumption that the ladder is uniform in your calculations. Good. Weight acts at the centre of the ladder. 1 mark. So when you look at this, what do you think makes this easier than the other ones? Why do you think this is easier than the other ones in some ways? Yeah, the n that we have here is a horizontal force, whereas in the previous ones we had, it was kind of like at an angle, so it required this additional stage of things here. But we're not going to need that additional stage of things because it's already perpendicular as it is. So it's a really challenging question, but when you look at the amount of maths that there is on the page, for probably a 10, 11 mark question, there's not much maths on the page because all of the marks are in here, here, and here, and then just a little bit of solving equations that you've got towards the end, okay? I'm going to go on to the next page, and I can put this one up later if you need to finish any of these things, but I can leave it here for 30 seconds. If you have finished writing all of that stuff down, you can have a look at the next question. Just begin reading through it, starting to familiarise yourself with what it might look like, okay? The wall will not be slanted, but if the wall was slanted, the normal reaction would be perpendicular to the wall because it's a normal reaction. So we've sort of done some like that, like this one that was on the previous page where it was resting on like a peg. That's kind of like a sort of slanted wall in some kind of way. So it will always be like a ladder in real life, just resting against a wall, okay? Sadia, what was your question? No, what was it? Okay. Okay. So I'm going to do the last ladder question, then you'll do a little bit of practice, and then we'll do some hinges problems. And then on Thursday, bless you, on Thursday we're going to do a bit of practice, and then we'll move on to our very final mechanics topic, which is only a 2-lesson topic. Okay? So, here we go. We have a ladder. This time there's no diagram, so we're going to need to build our own. A ladder AB of weight W and length 2L. They love to not give numbers for this. They love to just use letters the whole time. Has one end A resting on rough horizontal ground. The other end B rests against a rough vertical wall. So here's a double rough example. I wanted to make sure to show you a double rough example. The coefficient of friction between the ladder and the wall is 1/3. The coefficient of friction between the ladder and the ground is mu. Friction is limiting at both A and B, which is good, because that means we can just use the F equals mu r. The ladder is at an angle theta to the ground, where tan theta is 5/3. So you can now see in that previous one where I created a tan theta, this is going to save us a bit of time because I'm never going to have to do anything with the sine and cos. The ladder is modelled as a uniform rod, which lies in a vertical plane perpendicular to the wall. Find the value of mu. So it's pretty similar to the previous one, okay? I'm going to start off with my diagram where I'm going to have a floor and a wall and a ladder. I have an angle theta here, and I'm going to have the weight acting in the middle, and the weight is either side, because it's uniform, the letter L. Now you're probably wondering, why am I writing my L like that, like this? Whoops. I write it like a posh kind of L, so it doesn't look like that, because that looks like a 1, and that's really confusing. So I like making sure my L looks like an L and not a number. There's some other forces that need to go onto this diagram though. Zubair, a couple of forces you can tell me about? Yeah. Which reaction force? on the ground. I'm going to call that one traditionally R, and then another reaction force. Sometimes they call this one S, but I don't like using the letter S because it looks like a 5. So I'm going to use the letter N again, but don't be alarmed if you come across a different letter. There's still some more forces. Muhi, any other forces?
Friction on both the ground and the water.
Yeah, which direction is this friction going to be?
Towards the right.
Towards the right, because we think it's going to be slipping to the left. So there's going to be a mu R here. And what about this one? Careful, it's going to be upwards, because if it's here, it's going to try and slip downwards. And if it's slipping downwards, that means the friction is going to be upwards. And we know that the coefficient of friction is a third. So it is a third N that we have there. Okay?
Is the coefficient of friction different?
Yes, the coefficient of friction between the ladder and the wall is a third. The coefficient of friction between the ladder and the ground is mu. So they're different materials. Yes, Hamza?
Does the friction count as a force?
Of course.
Okay.
Yeah, the friction is a force. Yeah, definitely. Okay, so Ruhan, could you do one of those 3 things for me? You can just tell me whichever one you want to do. You know the 3 things I'm talking about, right?
Left, right.
Okay, good. Left, right. So he's going to resolve left and right for me. What do you get? N is equal to mu R. Ibrahim, can you do another one for me? You can do a choice of 2 now.
I've done R equals W plus a third N.
So he's sum resolving up and down. So R equals W plus a third N. I'm not sure I agree with you.
R plus.
Good. R plus a third N is equal to W. We can all do those marks, even if you're in a panic at the end of the exam. Last question, last paper. You can all get these marks. Who wants to do the harder part with me? The moments part. In fact, I might do the moments part because this is my example to really show you guys. So we're going to take moments, and I haven't actually labelled where the different points are because sometimes it gets a bit too busy, but that's A and the other end is B. So I'm going to take moments about A. I could take moments about B if I wanted to, but this is a good place to do it because I'll get rid of R and I'll get rid of mu R. But it doesn't really matter. You can take moments at either of those places. Okay, so which of these, there's 1, 2, 3, 4, 5 forces. Obviously 2 of them aren't going to matter at all. Which 2 forces are working together? N and a third N are the ones that are working together because they're trying to make it go around in this direction. The W is trying to make it go around in this direction. So I'll start off with the W one. And again, I'm going to draw on that line of action of force. And I'm trying to find out the shortest distance from here, running along the bottom. So if I do a quick sketch of that triangle, I have L and I have theta, and I want the distance running along the bottom, which will be L cos theta. So that's going to be the force, which is W, multiplied by L cos theta. Now I know it's going to be equal to these 2. Okay, these 2 are going to be separate ones. Now I'm going to deal with, which one do you want me to deal with first, the third N or the N? N. Okay, so I'm going to look at the N. I'm going to look at the line of action of the force, and I'm trying to find the shortest distance between this point and this line. So I'm actually looking for this distance that I've got here. Now, if that's theta, I know that one's going to be theta when I draw my triangle. So here's my triangle. Here's my theta. Here's the distance I'm looking for. What's the hypotenuse? 2L. What's the distance then? 2L sine theta. Thank you. So you get N, which is the force, multiplied by 2L sine theta. And now we're going to do the last one, which is this third N. I'll do it in red. Extend the line of action of the force. And you're trying to find out the distance from here to the force. Okay? So again, I'm going to draw a triangle. The hypotenuse is 2L and the angle is theta. And I want that distance along the bottom, which is 2L cos theta. So it's going to be a third N multiplied by 2L cos theta. Before we do any substitution, I should do a bit of tidying up. What's the tidying up here? Cancel out the L. Like in the previous question, we cancelled out A, didn't we? You should always find that if there's an unknown distance, it's going to cancel out. Because when you take moments, they all involve the distances that you've got, right? So I can cancel out the L, and the L that I've got here. And what else does it look like I'm going to need to do? Pardon? I could divide by cos theta. Now, pardon? I can just divide by cos theta and you'll see what will happen here. The reason I'm going to divide by cos theta, I'm just going to do a quick bit that's not massively to do with the question. If tan theta is 5 over 3, and I drew that triangle where this is 5 and this is 3, the hypotenuse would be, what's that, 25 plus 9, which is 34. We get root 34, so I'd have to be saying that sine theta is 5 over the root 34. I don't want to be dealing with that. I don't want to be dealing with root 34 because it clogs my brain up. I just want to be dealing with something nice and easy, like tan theta is 5 thirds. So I'm going to divide by cos theta just to tidy up and see things look a bit nicer. So I get W equals 2n tan theta plus 2/3 n. Okay? Do you see how I divided by cos theta, divided by cos theta, and divided by cos theta to get 1 tan theta and 1. Now tan theta is 5/3, so I'm going to replace that with 5/3. So I get W equals 2 times n times 5/3, which is 10/3 n plus 2/3 n. So W is 12/3 n, which is 4n. So all I now have to do is tackle this, this, and this. Obviously, this is the one that has the most work. Do you notice how that dividing by cos theta made my life so much easier? I didn't have to use a root 34 anywhere. You should do that with ladder questions. If it's getting messy, you should be, hang on a second, can I create tan thetas out of this? Okay, so I just want to find out what mu is equal to. What do you think is going to be the best thing to do? I'm probably going to sub that in here. So I'm going to say if this one is number 1, number 2, and number 3, if I sub 3 into 2, I get r plus 1/3 n equals 4n. So r is equal to 11/3 n. And now if I go to the top one, if I sub into number 1, I get n equals mu multiplied by 11/3 n. So dividing both sides by n and multiplying through, I get mu equals 3/11. So you're going to do a little bit of practice on this for 20 minutes. You're going to do 1 or 2 of those questions in that time. Yeah, Hamza, what's your question?
You see for n, the green one.
The green one, yep.
Why didn't you just do cos theta? How do you know which one's longer, which one's shorter?
So for this one that I've got here, this is the line of action of the force n. We're trying to find out the perpendicular distance of the force. This is the direction of the force between, so this is the point, and this is the line of action of the force. The perpendicular distance is the shortest distance between them, okay? If you did cos, you would have been finding out that distance, but that distance has got nothing to do with that point.
Yeah.
And if you do one of these questions and you have like cos, 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 you've done it wrong. If you have sine, 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 you've done it wrong. So you have to have a combination of cos and sine, which is great because you're only going to be able to do this trick here that combines it to a tan and just leaves everything in those nice kinds of numbers. Good. It's the distance between the point and the direction of the force, okay?
Yeah.
So, yeah, it's moments, yeah. So you've got, I'll leave it on this page though, you've got this one, and this one to do. I'd love it if you can get 1 or maybe 2 of them done in this time. And I would probably think this is one of the times that's worthy of doing some stuff on the whiteboards. So let's go.